So now we have Mr. Manoj Kumar, next speaker. He's founder KJSS Cosmos Private Limited. He's an international executive diploma in project management, PG diploma in shipping and export management, and a BE electronics. He has over 30 years experience working with groups like JSW, JSPL, SMS Group, SR Group. And presently he's worked as a head of project in JSPL and in close relationship with promoters and other stakeholders in delivering, planning and assisting projects at multiple locations. Over to Mr. Manoj Kumar for his presentation.
Thank you. So first of all, I would like to thank PHDCCI for giving KJSS a chance to present at the important event. And we have built AI-powered platforms like PROCA, is a procurement assistance, and for transparent procurement and cloud-based system, and for the plant operation. We are looking for support from the government or industry for R&D and proof of concept of opportunities. Even though we partner globally on carbon capture universities in China and with the companies like Baowu, and we face big challenges with our working capital. Anyway, now let's take you through the KJSS different portals and the design. So the KJSS basically working in different areas. So our key offerings are real-time production intelligence, predictive maintenance and quality AI modules, smart procurement platforms, and customized mobile apps and robotics. And the system which we have developed, which we call like Plant on Cloud, it's a basic system which can be adopted. It's like a program logic controller. Those understand level 1. So we have created the elementary languages there, and you can use those tools to create your own AI tools or AI requirement as per your process knowledge. So it can be used in the steel sector, like for blast furnace silicon prediction, coke quality forecasting, sinter strength prediction, degassing carbon prediction, cobalt prediction, as well as cold rolling surface and yield strength prediction. So majorly it gives us the real-time production intelligence. It gives us the predictive maintenance. It gives us the smart procurement platform. And we are developing some customized mobile apps and robotics for the different industries. So just in brief about PROCA, it's a smart procurement platform. What key features are there? That it's a real-time vendor collaboration. We have created more than 4,000 plus steel product templates. All approval workflows and costing tools are created. It has both the versions, SaaS as well as standalone. And it supports in the clean sheet costing, bidding, audit trails, and full task visibility. We can adapt this system as per our requirement. We'll discuss in detail in our later presentation. And majorly, how do we like to deploy and what is our commercial proposal? The engagement model is like this. We are available for online demos, and beta versions are already available. On-site proof of concept deployment by KJSS engineers. So initially, to do the proof of concept of this softwares, we are not charging anything on the software part. Engineers will build as per the man-month basis for the integration and tuning till the time the software is meeting all the requirement of the client. And there are many innovative projects which we are working parallelly, like mobile-based fire extinguisher tracking, gas pipeline mapping, and robotics partnership. So going into the PROCA, Procurement Assistance Portal. So in this you can see like phase 1 and phase 2. Phase 1 we have completed. Under the phase 1 basically PROCA beta version is available. Organization management is available. Workflows are available. Vendors onboarding, pre-built templates and template creation and revisions. And the enhanced workspaces and internal workflow enhancements are already completed. Phase 2 and phase 3 is under progress. Our major objective is to revolutionize the procurement process for steel manufacturing industry, leveraging our deep industry expertise and continuous innovation. So in case of Proca, basically, how does it work? It takes the part which you can see on the screen left hand side. In the SaaS version, it is taken care by the KJSS Proca admin. So basically, we have created 4,000 templates. In case if any requirement is there from any of the steel plant, that requirement is given to the Proca super admin, and it selects the relative product templates and get it modified with our advisory to the requirement of plant, and then this template is given to the plant. Then plant can create their technical workspace, commercial workspace, procurement workspace, approvals, negotiation, and any others. So for each workspace, there will be a key account manager, and he can define the jobs and responsibility. And he can invite any kind of vendors to this. We also have a specific vendor suggestions. So basically, the task creation, task management, task approval, vendor invitation, vendor management, group formation, approvals, chat creation, chat history is available on the system throughout the life. So what we can say that from RFQ to the PO placement, everything is available there, and all the members will be working on the same platform. So all data will always be available with us. We have taken out the usage of like email, sending RFQ and all this thing, that is taken out. And AI based, there will be a technical comparison, technical rating, commercial comparison, and commercial rating. So major advantages will be enhanced transparency, data visibilities, audit trails, direct communication with vendors, real-time chat, and vendor input integration, and the negotiation tools. It gives us the prevention of malpractices as well as secure and reliable setup is there. So major advantage is like this, like pre-built configuration is there, multi-role organization is available, easy vendor onboarding is there, and real-time RFQ comparison and customizable workflows are there. Our next product is Plant on Cloud. Here we are referring to the real-time production intelligence. However, it's a basic foundation of the AI system. So we can tune it as per our requirement. I'm just sharing few use cases with respect to general industries as well as the steel industry. So how it works, it takes out the data from OT platform to the AI platform, and then this AI accelerator will pass on this data to the AI platform, and accordingly the system will take all the required decisions. Basically, the data will come in the form of like process data, asset data, energy data, cost data, quality data, 3D video, and others. So basically, we have an option here for in building it with the 3D files. Either it could be NVIDIA or anything else, and we can interface it with the OT data so that we can have a realistic walkthrough to the plant, and many other things will be there. And it works with the offline as well as online data. Data is organized in terms of domain knowledge, handles millions of data points, and same product works for different sites. No additional development is required. So the major value proposition what we get is there is no data coding, no hassle, and unparalleled data insights are available, and it talks in the manufacturing language is talked in the human language, and it is compliant with the industry 5, and it's scalable and cloud ready. Cost reduction and sustainability options are there. Predictive asset maintenance as well as ease of implementation is there. This what we are showing like a 3D model. It's a water purification system. So we can inbuilt with any kind of 3D images as well as 3D files, and on that basis we can put our data as well as we can do the analysis on this. it's the example of like we understand chat GPT, but it is like machine GPT. Basically like say take an example of a blast furnace. If a blast furnace is being newly built and we have the data of the old blast furnace, we can import that data to this file and it can help us in learning and easy commissioning of the new blast furnace. So like this, if we have the data available of any old plant, we can get the analysis done. Or if the data is available of the present plant, we import those data and we can ask any questions related to that data. So basically there are two kinds of system. One is rule-based expert system and another is the pattern-based system. So both the systems are available. And stepwise guide to artificial intelligence. Basically it gives us what are the different steps in case of artificial intelligence. Step 1 is like descriptive AI, where we do the root cause analysis. Step 2 is the diagnostic AI. It is for like enhanced automation, like for anomaly detection and clustering. Step 3 is the predictive AI, which is like optimal resource planning via forecasting and classification. Step 4 is the prospective AI, assist in design and decision making. And step 5 is the generative AI. We'll discuss on there with the examples also. So building blocks are like all the data sources, infrastructure and technologies, algorithms, and identifying the opportunity and managing those blocks for the AI strategy. These are the different, basically it's as what I mentioned, it's a tool which is not limited only on the OT data, that can be implemented to the whole organization. And it has no limit of any kind of integration. If say I take an example of a company like JSW and others, those are having plant at multiple locations. So all the data of the multiple location plant can be integrated with the one system. And they are like business analyst, financial optimization, document management system, quality control and production control, IT support, human resources, engineering, all and everything can be merged with one system so that we can have a very good comparison on those. Am I audible now? Is there not any issue? Hello?
Yes, you are audible.
Okay. We'll have a Q&A after this. And what I was mentioning about the different steps, like in case of diagnostic AI, we get the data from the different sensors. And in case if any sensors are not readily available in the market, we have a tie-up with the companies. Those can create a sensor as per our requirement. And like temperature sensor, which can detect the like anomaly score and all these examples are very known. Similarly, on the predictive AI, basically we can get information like remaining useful life forecasting for such as compressor, gearbox, pumps, turbines, bearings, etc. For like predictive AI, we can get the predicting net hourly electric energy output. These are the few examples which I have explained here. However, depending upon the time limitation, I'm not going in depth of this. Prospective AI and basically how the AI system works. In case of prospective AI, that we put our questions, like I was mentioning for machine GPT, we put our question in the human language and we get our answer also in the human language. Internally, whatever is happening in the database, tables, as well as the patterns are taken care by the system itself, AI engine itself. We can have any kind of dashboard. We can modify as per our requirement. There is nothing like standardized kind of a thing. It's just like plug and play. No, this software writing and coding is required for this. And enhanced monitoring, predictive maintenance, quality control, operational efficiencies, this can be covered through this. So, role of AI agent in manufacturing, like the problem faced, solution offered, and giving the benefits to this. So the next is we are presenting here the use cases in steel manufacturing. Like in case of steel manufacturing, basically it's a very complex process. There are a lot of data at the blast furnace at many different places, and it cannot be compared without the AI system. So basically comparing it with the running pattern and with the old pattern, we should have AI in our steel manufacturing. And the system, the base which we have designed, it can take care of all this. And as what I mentioned earlier also, what we are offering, that initial cost of software will not be there. And the engineers which will depute to your site for tuning and controlling purpose, this only will be charged till the time you are satisfied with the results. And like AI in steel manufacturing is the need for the real-time decision making, optimization for quality, energy and yield, and enhanced traceability and predictive control. So here some few examples which we have taken, like Fe recovery prediction for mineral beneficiation, coke property prediction, sinter strength and predictive prediction. Like this, we can have many different kind of predicted outputs, like for hot metal, silicon and temperature prediction. Basically, the person who has the knowledge of process, all the AI tools are already available in the library. So he can himself design and plug and play with that. PUF slag chemistry prediction and degassing carbon content prediction, hot rolling UTS and YS prediction, cobalt prediction, and etc. etc. There are many such kind of use cases we can use. Normally detection in cold rolling mills, material tracking in billet mill, business impact on blast furnace silicon, and AI across the steel value chain, like beneficiation will give us the maximized recovery, coke and sintering will give us the stabilized inputs, iron and steel making will give us the optimized chemistry, rolling will ensure the mechanical properties, and CRM implementation will give us the maintenance tracking and quality. So that's just in brief about the KJSS digital system.
Thank you, sir. Thank you for giving a glimpse of your new technology, and I think it will be very useful for the mining and steel sector. Thank you for joining us.
Thank you, sir. And I would like, in case if anybody has any question, I will prefer to answer their questions, or anybody in the online platform may ask through the Q&A section.
Right. Thank you, sir.